Alright, dear children, now we move to the terms related to radiation. Okay, now there are a number of terms that we can define as the radiation process is concerned. And in radiation, we get what energy? Heat energy from the body, okay, without heat energy from the body. And this heat energy which get from the body is actually also known as what? Thermal radiation. Also known as what? Thermal radiation. Okay, like sun gives us heat energy to the earth in the form of what radiation? Thermal radiation. Like in the same way, like electric bulb, that electric bulb also gives what? Radiation. Electric bulb also gives what? Radiation. And it gives light also, but in the form of heat also. And this radiation which is received from the electric bulb is also what? Thermal radiation. Okay, that's why remember, children, this part, that radiation is actually the what? Oscillation. Remember this part, that radiation is the oscillation of two fields. I'm just adding out a two field. One is called electric field and magnetic field. And children, the detail of this electric and magnetic field you learn in class 12 only. And this electric field and magnetic field which oscillates in such a manner, so the oscillation of this electric and magnetic field can reaches from one place to another place in the form of wave. And this wave is called electromagnetic waves. That's why radiation are nothing but the electromagnetic waves that reaches from sun to the earth. Okay, and the details of electromagnetic waves I'll teach in class 12, because this is one of the chapter that you learn. Okay, but out here we are basically concerned more about the terms related to radiation. Now, to understand more terms about radiation, one of the term that we need to define is called reflectance. One of the term that we need to define is called reflectance. Then after we have another term to define, that is called absorptance. Okay, then after we have the third term to define, that is called transmittance. Transmittance. Then after we have another term to define, that is called emissive power. So we need to understand about emissive power also. Okay, then after we have a term that is called emissivity also. Emissivity. So similarly, there is a term that we need to define, is called spectral absorptive power. So these are the terms that are related with radiation. Radiation. Now, to define these particular terms, so let me just tell you that when a thermal radiation from a source fall on the surface, suppose, okay, this is a body, this is the source which give us what? And radiation, thermal radiation. Thermal is related to what? Heat. Thermal radiation. When this thermal radiation from the source fall on the surface, it falls on the surface of a body. It falls on the what? Surface of a body. So basically what happened? Then some part of this thermal radiation, okay, will be reflected by the surface. There is a reflection takes place. Some amount of thermal radiation is reflected by the surface. Some amount of thermal radiation is absorbed by the surface. So there is absorption takes place also, absorbed by the surface. And some remaining part of this thermal radiation is transmitted. It transmits also. Transmitted by the surface. So it's not that whatever thermal radiation that fall on the surface is all thermal radiation is absorbed by the what? Surface. But this absorption rate, transmitted rate and reflected rate is not same for all the bodies. It depends upon the materials of the body. Okay, but the consideration is that by what amount, total amount of this heat thermal radiation that is fall on the surface is absorbed by the surface and is reflected by the surface and is transmitted by the surface is actually defined by the three terms. The first three terms, that is called reflectant, okay, then absorptance, then transmittance. Okay, so for that, let me just consider that let Q be the total amount of thermal radiation, total amount of what? thermal what? Radiation falls on the surface. Falls on the what? Surface. So from a given source, okay, how much amount of thermal radiation is falling on the surface of a body? Q. Then out of this total amount of thermal radiation fall on the surface of a body, then some part of radiation is reflected by the surface, and that part I write down as Q1. So P1 be the what? Part of thermal radiation. This is the part of thermal radiation, okay, reflected by the surface. Reflected by the what? Surface. That means that surface reflect this much part of the thermal radiation falling on the surface. Similarly, I write down, say Q2 be the what? Q2 is also be the part of what? Thermal radiation. Q2 is also the part of thermal radiation. Okay, and this thermal radiation is absorbed by the surface. Thermal radiation absorbed by the surface. And lastly, remaining part out of Q amount of heat or thermal radiation falling on the surface, these two are the amount of thermal radiation, part of thermal radiation which is reflected by the surface and absorbed by the surface. So definitely the remaining part of the thermal radiation must be transmitted by the surface, and that part I will consider as Q3. So Q3 be the what? Be the remaining part. Okay, let me write this way. Be the remaining part of what? Thermal radiation. Radiation that is transmitted by the what? Surface. So as for this radiation of absorption, reflection and the transmission of radiations of concern, okay, we can simply write the relation as Q1 plus Q2 plus Q3 equals to what? Q. Means the part of thermal radiation reflected by the surface, part of thermal radiation absorbed by the surface, plus part of radiation, remaining part of thermal radiation transmitted by the surface. Their sum must be equal to the total amount of thermal radiation falling on the surface. Okay, and this is always true. Okay, because as for the law of conservation of energy is concerned, energy can neither be created nor be destroyed, but can simply transform from one body to another body. Okay, so the total energy remain constant. So following the law of conservation of energy, so this relation is always valid. So let me just give this equation as 1. So what I do, I just divide both sides by Q, dividing, okay, both sides by capital Q. So if I divide both sides of this equation 1 by capital Q, then we write down this as Q1 by Q plus Q2 by Q plus Q3 by what? Q equals to Q by Q on the right hand side. So Q by Q simply cancel out and become 1. So you can see the relation now. This Q1 by Q plus Q2 by Q plus Q3 by Q is equals to 1. Okay. Now in this relation on the left hand side, you can see the first term, that is Q1 by Q, is actually nothing but replaced by letter R, and this small letter R is actually called as reflectance. This is called what? Reflectance. So children, reflectance is nothing but the ratio of Q1 by what? Q. The part of that thermal radiation, of total part of thermal radiation which is falling on the surface, which is reflected by the surface, and that ratio, that measure by the amount of what? Thermal radiation reflected by the surface, of that total amount of thermal radiation fall on the surface, is simply given by the factor that is called R, and this R is called reflectance. Similarly, this factor Q2 by Q is expressed by the symbol what? A, and outer A is called absorptance. This is simply called as what? Absorptance. So write down absorptance, and absorptance is simply marked by letter A, and this A equals to Q2 by what? Q. Okay. Similarly, the third factor that you can see is marked by letter T, small letter t, and this small letter t is called transmittance. Transmittance. and it is symbolized by a small letter t, and small letter t equals to q3 by what? Q. So in the relation you can see q1 by q is called R, reflectance, q2 by q is called A, that is called absorptance, and sometimes this is also called absorptive power, okay, and q3 by q is called transmittance. So as for the surface is concerned, okay, I write down the relation now. This as this I replace by R plus this quantity I replace by A plus this quantity I replace by T equals to 1. So for any surface, okay, in which the radiation which fall on the surface, okay, for a particular wavelength, so I am using the word for a particular wavelength, okay, R plus A plus T is always equals to 1. Means this relation, that means the sum of reflectance, absorptance and transmittance is equals to 1 is true for a surface. True for a surface for a particular wavelength. For particular wavelength of radiation. Now why this particular term like wavelength has come? Because radiation which travel actually in the form of wave, electromagnetic waves, and waves has what? Electromagnetic waves has a wavelength, and this electromagnetic waves which fall on the surface of particular wavelength, okay, on the surface follow the relation that R plus A plus T is always equals to what? 1. So this is a very important relation as for the reflectance, absorptance and transmittance from the surface of a body is concerned. Now from here we discuss some special cases. Children, we have some special cases to discuss now. Special cases. Okay. Now one of the first special case that I discuss is, suppose there is a body, okay, whose transmittance is 0. That means that body is not transmitting any radiation when it falling on it. Means if the transmittance is simply 0, then what happen? Then we can simply write as, from the relation I write down R plus A plus this T is 0 equals to 1, which means R plus A equals to 1. And this relation simply say that R plus A equals to 1. Now this R plus A equals to 1 even say that a body having large value of R, large value of what? R, will have smaller value of what? A. If the value of R is large, the value of A must be small. Okay, so that body, if it is a good reflector, then that body is a bad absorber. A good reflector of a body are the bad absorber of heat, and exactly vice versa. Means if R is large, A is small, and if A is large, R is small. Okay, which means if a body having a good reflector of heat has a bad absorber of heat. At the same time, if a body have good absorber of heat has a bad reflector of heat. Okay, and that means this particular case say that good reflector is a bad absorber and good absorber is a bad reflector. So this is one of the special case from this relation. Now we have next special case. If a body has R0, reflectance 0, and T0 means transmittance 0, means this statement simply say that a body neither reflect nor transmit any radiation falling upon it. So in that case what happened? We know the relation R plus A plus T is equals to 1, which means 0 plus A plus 0 equals to 1. What do you mean by this? Now this is A equals to 1. That means body only absorb the amount of heat, energy or thermal energy falling on it. Means this is the case where the body neither reflect nor transmit any radiation falling upon it. So in this case, A equals to what? 1. So when A equals to 1, then we say that the body will absorb all the incident radiation falling upon it. And such a body is actually called as perfect black body. Perfect black body. And I am using the word black. You know, black is a good absorber of heat. And perfectly black body means that body which absorbs all the amount of heat that is falling on it. Means that body which neither reflect the heat nor transmit the heat. And such body are called perfectly black body. So this is the case which happens when the body what? when the body what absorbs all the what all the incident radiation, all the incident what radiation, and such body is called perfect. I use the word perfect black body. Perfect black what body. So perfect black body is such a body when that body absorbs all the amount of heat that is falling on it, or heat energy or thermal energy falling on it, so that that body neither reflect the heat energy or not transmit the heat energy, and such body is called perfect black body, also called as perfectly black body. And children, another point that you need to keep in mind for perfectly black body is that this body is absorb completely all the radiation falling on its surface, whatever be the wavelength. In whatever wavelength the light fall on the surface, that body absorb all the what radiation falling on it. So that for perfectly black body, I write on A lambda equals to 1. A lambda equals to what? 1. Means the absorptance for that body, or absorptive power of that body for all the wavelength. This is for all wavelength. Whatever wavelength of light or wavelength of radiation which fall on that body, okay, so for that the absorptive power of that perfectly black body is always equals to what? 1, where A lambda equals to 1 is same for all value of lambda. Okay, so this is one of the important case for which we understand about the concept of what? Perfect black body or perfectly black body. So I have defined 3 different terms related to the radiation. So there are other terms to define also, and that you learn in the next YouTube video.